Hey everyone, and welcome. Today we're going to crack the code. The secret language that powers, well, pretty much everything digital. So let's just jump right in with a question.
Seriously, have you ever stopped to think about this? How does your phone, this slick piece of glass and metal in your hand, how does it actually understand what a selfie is? Because it's not seeing your face, not like you and I do. It's seeing something totally different.
And that something else, well, it's a secret language. But don't worry, by the end of this, you're going to get the basics. We're about to pull back the curtain and see exactly how all our favorite gadgets really talk to each other.
All right, Section 1, a computer's secret language. We're diving into how machines talk using just zeros and ones.
Okay, check this out. When we type the letter A, our brain just sees, well, an A. Simple enough, right? But a computer? It sees this, a string of numbers. It's a huge clue that computers don't think like us at all. Their system is way, way simpler.
And that system? It's called binary code. You've probably heard of it. It's basically the native language for all computers. And the entire alphabet is just two numbers, 0 and 1. The easiest way to think about it is like a simple light switch. Deep inside your computer, there are billions of these tiny switches, these little electrical signals. If a signal is off, that's a 0. If it's on, that's a 1. That's it. It sounds almost too simple, but believe me, it's incredibly powerful.
So, if the whole language is just zeros and ones, you might be asking, what are the actual letters, the words? Well, to figure that out, we need to meet the smallest building blocks of all digital information, the bit and the byte. Okay, let's start with the smallest of the small. The absolute tiniest piece of data a computer can possibly understand is called a bit. It's just short for binary digit. And a bit can only ever be one of two things, a 0 or a 1. That is it. It is the atom of the digital world. You can't break it down any further.
But, a single bit by itself can't say much. It's like having only one letter of the alphabet. That's why we have the byte. A byte is just a team, a group of 8 bits all working together. And by arranging those 8 bits into different patterns of zeros and ones, a computer can suddenly create codes for all sorts of things. Letters, numbers, symbols, just like that letter A we looked at a minute ago.
Here's a great way to picture it. A single bit, that's like one tiny bead. But a byte, that's like a whole bracelet made up of 8 of those beads. See, one bead by itself is just a bead, but a whole bracelet? Now you can create patterns, designs, something way more meaningful. And that number, 8, is kind of the magic number here. It's always 8 bits in one byte. Remember that. It's such a simple rule, but it's the key to understanding almost everything, from how big a file is to how fast your internet is. Okay, so we've got letters and symbols figured out, but what about just regular numbers? How do computers count? Let's get into it. Next up, counting in computer speak. We're going to see how they get from binary to the numbers we all recognize. So when a computer sees a sequence like 1010, it makes perfect sense. But to us, it just looks like a random string of numbers. But here's the crazy part. That string actually represents the number 10. So how in the world does that happen? Let's break it down. It's easier than you think. It's actually all about place value, kind of like in elementary school math. So first, you take your binary number, in this case 1010. Then, starting all the way on the right, you give each spot a value and you just double it as you move left. So it goes 1, 2, 4, 8. And you'd keep going if the number was longer. Now for the final step, and this is the easy part, you just look for the ones and add up the values above them. So here we have a 1 in the 8's place and a 1 in the 2's place. And what's 8 plus 2? It's 10. And there you have it. See? Not so scary after all. All right, so we've gone super deep, all the way down to the individual bits. Now let's zoom back out and connect all these dots. Let's see how this stuff actually comes together to create your entire digital world, from these tiny bits all the way up to your selfies. So you might be thinking, why does this even matter? Well, it's everywhere. That binary code we talked about, that's what's running your favorite apps, your video games, everything. Those little bits, we measure how fast they can travel when we talk about internet speed. Megabits per second. And the bytes, that's how we measure the size of our files, like a 5 megabyte photo. It all connects back. And honestly, if you take one thing away from this, let it be this. Everything on your phone, your laptop, your console, it's all just a giant, massive collection of zeros and ones. That selfie you just took, it's really just millions of zeros and ones. That song you're streaming, a totally different but just as huge pattern of zeros and ones. At the very bottom of it all, it's just binary. Which really leads us to a simple but powerful truth. Without binary, computers would just be, well, expensive paperweights. They couldn't do anything. It is the absolute foundation, the language that makes our entire digital world possible. Every time you click, every time you swipe, every single command gets translated back down into that simple on-off language.
And that leaves us with a pretty cool question to think about, right? If this super simple, two-digit language of just zeros and ones was powerful enough to build this incredible digital world that we have today, what's next? What are the building blocks of tomorrow's tech going to look like?